Good afternoon to all of you. Welcome to another session of mathematical logic. My name is Satish and today I will tell you the nested quantifier with inference rule. See, many times the students are having the problem when the persons will be trying to understand the nested quantifier. So today's topic you can only understand when you will have the concept of what? The concept of you can say that the nested quantifier and then welcome to another session. Nested quantifier and then you can say that inference rule. So you can only understand this concept when you will have the concept of a nested quantifier. So you should know what is a nested quantifier and you should also know what is the inference rule. So when you will be knowing both the things, then only you can understand the whole concepts. Okay. So yes, once again I welcome all of you on India's largest platform, e-learning platform on a Gradeup. Okay, let me tell you about myself. My name is Satish and I have taught for more than 8 years and I have trained more than 1 lakh of students, and areas of expertise are Discrete Mathematics, DBMS, and for ESC, ICT and Digital Logic. Okay, so let's talk about what the Gradeup is giving you, the advantage that you people can have. See, many times a student used to ask me, sir, how to prepare for any particular, you can say that the batches, or how you can go and how you can try to understand your preparation. See, let me tell you, a person's when he is preparing for any particular examination, then what will happen? You should be having the sequential manner of a preparation. So here the Gradeup is giving you all the things that you can have. So Gradeup is giving you 850 hours of a live classes and 8,000 of a practice questions. Even sometimes a student used to ask me, sir, how many number of questions will be enough to get a rank into GATE examinations? Then I'll be saying that you will require almost 10,000 number of questions. Here the Gradeup is giving you 8,000 questions, and obviously when a faculty will be teaching, he will be giving you more than 2,000 of questions. And one more advantage you will be having the hundreds of mock tests, you will be having the 120 of a chapter wise study notes that you will be getting. So suppose if you are thinking of joining a Gradeup, you can contact on this number, that is nothing but 9650052904. This is the official number which has been given by the Gradeup. So if you will be calling us, then the management will take care about each and everything. Right now it is April, and still if you people are thinking that how to prepare, then you are wasting your time. So how you can save your time? By taking the subscription on a Gradeup batch. So you can contact on this number, that is nothing but 9650052904, and if you will contact on this, the Gradeup team will take care about all of these things. And one more news to all the students, the Gradeup has also started the Hindi batch. So suppose if you are from Civil, Mechanical, EEE, EC or CS, then the Gradeup will also be giving you the large amount of advantage so that you can also join. Again, you will be having the 850 hours of a live classes, you will be having the 8,000 questions, you will be having 120 chapter wise notes, you will be having the hundreds of mock tests. Okay, let me go and let me try to give you the today's scenario and what I will be teaching you, which is nothing but a nested quantifier. But here, just wait, the Gradeup is also giving you, which is nothing but the free internet with the Gradeup Super. So if you are taking a subscription, you will be getting a free internet. Okay, let's go and let's talk about the today's topic. And what is that today's topic is basically the nested quantifier with inference rule. This is the last topic of a mathematical logic, and it will require a lot of concept to understand these things. At the first time, if you will try to understand, believe me, you will be require a little bit of background of this concept. So let me tell you how you can understand these things. The nested quantifier with inference rule. In order to understand these things, the first concept is there, and that is called as a universal specification. So here the first concept, that is called as what? That is called as a universal specification. So let me teach you what is basically the universal specification. We cannot directly jump to a nested quantifier with inference rule. There are certain rules that we will be understanding, and then we will jump to universal specification. So let me tell you what is the universal specification that you people are having. Suppose if I will write that for all of x, p of x is going to be true. Suppose if I will say that for all of x, p of x will be true. And if I will ask when for all of x, p of x will be true, then you will say that, sir, all of x, p of x will be true when each and every element in the domain are going to be true. Let's consider for all of x, p of x true. So here I am writing for all of x, p of x, let's consider the statement as what? The statement as a true. When this statement will become a true? Now this is my next question to all of you. When for all of x, p of x will become true? When all the elements in the domain are going to be true. When all the elements in the domain are going to be true. When all the elements in the domain are going to be true. Right? Yes or no? Going to be true. So we can say that for all of x, p of x, when it will become a true? When all the elements in the domain are going to be true. Now can we say that when for all of x, p of x will be true? Can we say that when all the elements in the domain are going to be true? Can I say that it will be true for p of a also? Let's consider, suppose if a domain consisting of 10 number of elements, then this p of a means what? It can be true for 1, it can be true for 2. So let me write this domain here. Suppose if I will take 3 elements. Now can I say that this p of a will be true for all the elements? So that means it will be true for p of 1, and it will be true for p of 2, and it will be true for p of 3. That means when I will take my left side as a true, can I say that p of a will be true? Where a is for all the elements. Where a is for all the elements. That is nothing but the concept that you people are getting. Where p of a, where a is for all the elements. That means it will be true for 1 also, it will be true for 2 also, it will be true for 3 also. This concept is called as a universal specification. We are specifying something. Always remember, this is very important concept. So when you are specifying that for all of x, p of x is going to be true. When this is going to be true? Can we say that when each and every element in the domain are going to be true? Yes or no? When we say that when each and every element in the domain are going to be true, actually universal specifications are, you can understand in another way, such that it is the utilization of a theorem. Suppose if there is one theorem, and we know that the theorems are applicable for any type of examples, irrespective of example. So suppose if I will write for all of x, p of x is true. Let's consider that is nothing but one theorem. So can I say that it will be true for all the elements? Can I say that it will be true for p of a also, where a is for all the elements? Yes, we can easily say that. Where p of a, where a is for all the elements. And that's how we will be getting. This is called as a universal specification, and shorthand notation we can use is, that is nothing but US. So we are specifying something. When we are specifying something, that is called as a universal specification. The next rule that we are having, and that is called as a universal generalization. This is called as a universal generalization. So we will try to go, this is a reverse of the first thing, and that is called as what? That is called as a universal generalization. So let me go and let me tell you basically what is a universal generalization. Suppose if you will have a domain consisting of 1, 2 and 3 number of elements. Now if I will say that p of 1 के लिए भी true आ गया, let's consider there is one open statement, and let's consider that will p of 2 के लिए भी आपका true आ गया, and let's consider कि p of 3 के लिए भी आपका क्या आ गया, true आ गया. So p of 1 के लिए भी true आया, p of 2. Let's consider the domain is only having 3 elements, 1, 2 and 3. So p of 1 के लिए भी true आया. We checked it. Okay, let's consider one example so that you can understand in a better way. So suppose if I will be writing p of x where x square is less than or equal to 9. What will happen if I will put the values of 1, p of 1? So you will be getting 1 square is less than or equal to 9. What will happen if I will put x equals to 2? So what you will be getting? You will be getting 2 square is less than or equal to 9. So for first one it will also come as a true, second one it will also come as a true. Now what will happen if I will be writing 3? So here you will be writing 3 square is less than or equal to 9. Again it will be also coming as a true. So suppose if my domain consisting of a 3 number of elements 1, 2 and 3, ये तीनों के लिए ट्रू आ गया, तो क्या मैं बोल सकता हूं कि फॉर ऑल ऑफ एक्स पी ऑफ एक्स के लिए भी ट्रू होगा? सो हियर आई कैन राइट इन अनदर वे विच इज नथिंग बट पी ऑफ ए वेयर ए इज रैंडम. What is the meaning of A is random? That means A can be for any particular element or A is for all. So I can easily write which is nothing but for all of x P of x with respect to this. Please like this session guys. Okay, if you are getting something, if you are getting a simple concept from this, please like this session. So this concept is called as what? This concept is called as a universal generalization. So this is the reverse of a universal specification. As you can see that here what we are having universal, what we can say that universal specification. So we are specifying something. So we are having a theorem and then we are trying to utilize this theorem into normal way, that is P of A where A is for all the elements. यहाँ पे क्या करते हैं, यहाँ पे we are trying to prove a theorem. So P of A is random, that means A is for all the elements. So here you can also understand this thing, that A is for all. A is for all the elements. A is for all the elements. Okay. So hence you will be getting what you will be getting for all of x, P of x. Okay. So here you will be getting this statement where P of A where A is random. This is called as a universal generalization. In the same way, so two things we have already understood. One, that is called as a universal specification. Okay. So we have understood universal specification. And second thing that we have also understood, and that is called as a universal generalization. Okay, that is called as what? That is called as a universal generalization. Now, in the same way, we are having the third one, that is called as the existential specification. So here you will be having what? Here you will be having the existential specification. So let's go and let's talk about what is basically the existential specification that we are having. Existential specification, what it says that? It says that, let's consider, if you are writing there exists of x, P of x as true, consider this as true. Okay, consider this statement as a true. When you will take there exists of x, P of x as true, what it signifies? It signifies that there might be existing of one element or at least one element where it will become a true. So if I will say that, let's consider, which is nothing but there exists of x, P of x as true. So when I will consider this statement as a true, what you can understand from this? You can understand कि there exists some element जिसके लिए क्या होगा, आपका true हो जाएगा. That can be one element, that can be two element, that can be three element, or that can be some element, or at least one element हो जाएगा आपका. So when I will take there exists of x, P of x as true, then what will happen? Can I say that P of A will become as a true? Now you will have a doubt. Sir, P of A for all के लिए true होगा or it will be for some element? I can say that it will be for some element, where A is for some element, or where A is basically what? Where A is basically fixed, right? So we can understand this. Whenever I will be taking there exists of x, P of x as true, it implies P of A, where A will become fixed. इसको क्या बोलते हैं? यहां पे स्पेसिफाई कर रहे हैं. जब हम लोग स्पेसिफाई करेंगे तो ये हो जाएगा एग्जिस्टेंशियल स्पेसिफिकेशन. ट्राई टू अंडरस्टैंड डिफरेंस बिटवीन यूनिवर्सल स्पेसिफिकेशन और एग्जिस्टेंशियल. यूनिवर्सल में क्या था? व्हेन आई एम राइटिंग फॉर ऑल ऑफ एक्स, P of x, देन इट सेज दैट कि P of A will be true where A is for all the elements. Where A is for all the elements. Now try to understand the existential specification. What this existential specification says that there exists of x, P of x will become true. Then it says that P of A will become a true where A is basically fixed element, right? That is called as the existential specification. In the same way, we are having also the another term that is called as the existential generalization. Let's go, let's try to understand this. That is nothing but existential generalization. Existential generalization. Now let's try to understand what is this existential generalization. Existential generalization क्या कहता है कि suppose if you are writing P of A where A is fixed, right? Suppose if you are writing P of A where A is fixed, so can we write there exists of x, P of x? Yes, we can write. So what we have to do? There is a domain जहां पे इसके लिए true आ रहा है. Let's consider here. Suppose if I will be writing P of x as x square equals to 4. And let me write my domain as a 1, 2 and then 3 elements. So here you will get 1, here you will get 2 and here you will get 3. Now I will go and I will ask to 1. 1, are you true? 1 बोलेगा नहीं, मैं तो true नहीं हूं क्योंकि 1 square equals to 4. So if you will be asking to 1, let's consider P of 1, तो 1 बोलेगा भाई साहब मैं तो false हूं. 1 square equals to 4, that will become a false. Now if I will put 2, then what will happen? 2 square equals to 4, इसके लिए क्या आ जाएगा? True आ जाएगा. So when I am getting my element, that will be for fixed number of elements, right? Yes or no? So here you will be getting what? Here you will be getting 2. So P of 2 के लिए वो क्या हो जाएगा? True हो जाएगा. So in this way I can understand कि P of A जब मैं इसको fix करता हूं, true लेता हूं, तो there exists of x, P of x भी मेरा क्या आ जाएगा? True आ जाएगा. This is the last rule that you will be having. That is called as what? That is called as the existential generalization. Let me give a summary of whatever I have taught. universal specification. So universal specification, what you are getting? You are getting for all of x, p of x, and it says that p of a, where a is for all. That means it is for all the elements. Let me tell you about universal generalization. What this universal generalization says that? यूनिवर्सल जनरलाइजेशन क्या कहता है कि जब मैं P ऑफ A लूंगा वेयर A इज फॉर ऑल, तो यहां पे जनरलाइज कर रहा हूं मैं. व्हाट आई कैन राइट इज आई कैन राइट एज फॉर ऑल ऑफ x P ऑफ x. जब मैं लेफ्ट साइड को ट्रू लूंगा देन द राइट साइड विल बिकम अ ट्रू. नाउ द नेक्स्ट वन दैट इज कॉल्ड एज द एग्जिस्टेंशियल स्पेसिफिकेशन. एग्जिस्टेंशियल स्पेसिफिकेशन. सो लेट्स गो एंड लेट्स ट्राई टू अंडरस्टैंड कि एग्जिस्टेंशियल स्पेसिफिकेशंस आपका क्या आएंगे. So if I will be trying to understand existential specification, it says that there exists of x p of x and then it will imply p of a. Now see the difference between the first and third. What the first and third difference? You will get where a is what, where a is fixed, right? That is nothing but existential specification. Now if I will be talking about existential generalization, so what I will be getting? Let's go and let's try to understand the existential generalization. Existential generalization, what it says that? It says that कि भाई साहब जब आप P of A where A will become what? Where A will become a fixed. When you are taking this element, then you can say that कि there exists of x P of x भी आपका क्या आ जाएगा? It will become a true. This is the concept that you people are getting with respect to. So now we are ready. Now we'll go and we can easily understand कि basically all the concepts कैसे relate करते हैं. So I have written all the things. Universal specification लिख दिया, universal generalization लिख दिया, existential specification लिख दिया. अच्छा ध्यान देना with respect to third and fourth one. The third one is basically existential specifications जहां पे मैं क्या लिखता हूं P of x. There exists of x P of x and it will imply P of A where A is basically fixed. Existential generalization when I will be writing, it says that where P of A, where A is fixed, it implies there exists of x P of x. So that's how you will be getting all the four elements 1, 2, 3 and 4. Okay, let's try to go and let's try to understand the real time application of that. We know one thing कि there exists of x P of x and it will and Q of x, it will imply there exists of x P of x and it will have there exist of x Q of x. We know that this equation is valid. We know that this expression is basically a valid expression. Everybody knows that. And you can also prove, so there are different methods to prove this expression. You can have, the box method which I have taught. If you don't know the box method, you can go and watch that box method also. So here you will have a box, you can use the box method and you can prove it. But let's go and let's try to solve the same thing with the help of without box method. Let's see what is our first premises. The first premises is there exists of x and here I will be writing P of x and Q of x, right? Now the second thing that I can write is basically P of A and Q of A. So when I will take the first one as a true, so what will happen? The second statement that I will be getting as a true, where A is what? Where A is basically the fixed element that you will be getting, right? So A has to be a fixed element. Now according to the simplification, so here you have to use the inference rule. According to the simplification from 2 and this, so 2 and simplification you can write which is nothing but P of A. Now according to existential generalization, what I can write is basically there exists of x P of x. So third and existential generalization. Now fifth one, what it says that I can easily write Q of A, and what is that? That is nothing but 2 and simplification. Again I have to use the inference rule. Now sixth क्या कहेगा? There exists of x Q of x. What it will say? It will say that fifth one and existential generalization. Now if you will take fourth and sixth, what will happen? You can easily write there exists of x conjunction P of x, and you will write there exists of x, you will be writing Q of x. So seventh we can prove it such that this will become what? This will become valid. We can easily say that कि आपका क्या आएगा? Valid आएगा. Everybody can easily understand. So this is the real time application that you people are getting. In this way you can understand the whole concept कि there exists of x, p of x and q of x, ये इसको imply करेगा, left side हमेशा imply करेगा. So there are certain rules. So how many rules you will be required? You will be required, which is nothing but you can say that कि there exists of x, p of x and q of x. It will imply there exists of x, p of x and there exists of x, q of x. So in this way you can understand. If you have a doubt, you can also ask me doubt, no problem into that. Okay, I hope it is clear to each and every person. Okay, fine. So as I told you, this equation you can solve with the help of what? With the help of two method also. You can also solve with the help of a block method. And you can also solve this equation with the help of this method also. Right? And we know that the right side will never imply the left side. Let's see what is the right side. We know that there exists of x, p of x and there exists of x, q of x. We know that it will never imply there exists of x and then you will have a p of x and q of x. Okay, so it will never be implying this. We know that. Let's go, let's try to prove with the help of this. So first, what I will write, there exists of x, p of x. The first premises what they have given, there exists of x, q of x. This is the first premises. Second premises what I will write, there exists of x, p of x. Which rule? 1 and simplification. Okay, 1 and simplification. Third one what I can write is basically p of a, where a is fixed. Where a is fixed. Now what will happen? Now you can write 2 and existential specification, because you are specifying something. When you are specifying, you will be having this. Now the fourth rule that you will be having, ki there exists of x and then q of x, you will be getting 1 and simplification. Now here you will be writing fifth, and here you can write q of a, where a is fixed. Now I am doing a mistake. Please try to find out that mistake. So second and existential specification. Now you will say that, sir, you have written this 3 and 5. So according to this 3 and 5, what I will do? I will try to do the conjunction. That means p of a and q of a, and then I can write there exists of x, p of x and q of x. Sir, कौन कहता है कि ये वैलिड नहीं है? हमको तो वैलिड आ रहा है. मैंने सारे रूल अच्छे से अप्लाई किए and each and every rule is valid. So why I am getting the wrong answer, or what is the mistake? आपने बोला कि पहला वाला एक्सप्रेशन हमारा वैलिड नहीं है, इनवैलिड है, but still I am getting my answer as a valid. So where is the mistake? The mistake is at fifth place. This is your mistake point. Now let me tell you why it is a mistake. Because p of a आप fix कर रहे हो इसके लिए, where a is fixed. Where you are fixing p of a here, right? Where a is fixed. So जब आप a p of a के लिए fix कर रहे हो, so you cannot write with respect to q of a, right? Yes or no? आप q of a के लिए नहीं लिख सकते हो, क्योंकि आप a को पहले ही fix कर लिए. Now here what you will be getting, this is basically with respect to q of b. You have to write q of b. This is nothing but your mistake. So hence we can say that the statement will become what? The statement will become invalid. So that's how we will be getting the whole concepts. Okay, that's how we will be getting the whole concept. So in this way we can understand कि basically ये आपका किस तरीके से you can have it. I hope everybody has understood what is a concept. Now, as we know that we have already understood and we have already seen all the concepts that is related to that. So that's it for the today, and I hope you have understood. If you have understood, you can share this video to all of your friends, and you can also like it. And suppose if you want to do a practice on this session, so every day at 5 p.m. you can join me on a Gradeup so that you can do a practice with respect to this type of questions. So suppose if you are thinking you want to do a practice with respect to this type of questions, you can join it. So what you have to do, you have to download the Gradeup app and follow me there, Satish Yadav, and then you can see all of my classes for free. And these are all of the faculties who are teaching on a Gradeup. So you can also go through all the faculties profile and you can learn all the concepts. See, the Gradeup actually has come up with the different types of learn. Every month we are coming with the different types of batches. So if you are interested, you can contact on this number, that is 9650052904. That is Gradeup official number, and our team will assist you in a best possible way. Okay, and as I told you, every faculty is taking the free classes, so you can also join. As you can see that the Deva sir is taking the class at 6 p.m. okay, and myself I will be taking classes at 5 p.m. every day, so that you can have a practice session on that. So in the same ways, the other faculties are also, Murli sir is taking the classes at 11, Ankit sir is taking a classes at 4 p.m. So you can also come and you can also join this session, and it is totally free. But if you want to prepare something, okay, the other faculties are also there. Navneet sir is there, Satya sir, Anshul sir. These all are teaching at different time. There is no classes, so you can join, you can join with respect to free. Okay. And suppose if you want to prepare the whole things in a streamlined manner, you can take a Gradeup subscription, because it will give you large amount of advantage, and then you can join and you can contact on this number. Okay, so yes, that's it for the today, and thank you so much for joining this session, and hope to see you in the next week. Okay, so thank you.